So welcome back guys. We're going to learn L2 switch in this module. So remember the problem of thrashing. So we discussed thrashing in the last module, that the rest of the machines in the subnet when two machines communicate with each other. Right? So let us deploy L2 switch in the network and understand how it solves the problem of thrashing. So what is actually thrashing? I am revising once again. For example, you have a wire which is also a LAN segment, and in this LAN segment or in this subnet you have a machine A and the machine B and machine C. So let us say the machine A, machine B and machine C are connected to the same wire, that is in the same local area network. Now let us say machine A wants to communicate with machine B. When machine A wants to communicate with machine B, it will prepare a Ethernet header as well as IP header. So when machine A wants to communicate with machine B, machine A will prepare a packet which contains Ethernet header and IP header as well as data payload. So that packet will look like something like this. So in that particular packet, which is generated by machine A destined to machine B, the Ethernet header will contain source MAC address, which is the MAC address of A. This is source MAC. And destination MAC address will be the MAC address of machine B. This is destination MAC. This is source MAC. Source IP address will be the IP address of the machine A, and destination IP address will be the IP address of the machine B. So this is IP header, whereas this portion is Ethernet header. Of course, there are other fields which I am not discussing because these four fields are the prerequisite for carrying out any communication on IP networks. So you can see when machine A wants to communicate with machine B, machine A will prepare the Ethernet header as well as the IP header as follows. After preparing this header, machine A will places the packet on the wire. Now when the packet is placed on the wire, it means machine A is generating electrical signals. Remember, packet is nothing but it is an electrical signal, that is 1, 0 varying voltages. So when the packet is placed on the wire, that packet will be received by all the machines which are connected to the wire. So machine B and machine C will going to receive the packet, right? But machine B will pick up the packet and the data link layer of the machine B will going to accept the packet because destination MAC address is equal to MAC address of the machine B. So that is why machine B will going to pick up the packet. Machine C, the physical layer of the machine C, picks up the packet and hand over the packet to the data link layer. But the data link layer rejects the packet. Why it rejects the packet? Because the destination MAC address of the packet is not equal to the destination MAC address of the machine C. So you can see that the physical layer of the machine C is unnecessarily busy. So it's the physical layer of machine C which is unnecessarily busy in picking up the electrical signals which are placed on the wire by the machine A, and machine C pick up those signals. The physical layer of the machine C converts those signals into packets, hand over that packet to the data link layer, and data link layer simply rejects. So you can see that the machine C is overburdened. Unnecessarily it is doing useless work. That is called thrashing. That is, machine C is being thrashed. So L2 switch solves the problem of thrashing. Consider a scenario in which there are hundreds of machines connected to the same wire. The problem of thrashing is more agreed there. So L2 switch is also called a bridge and it is a layer 2 device. Why it's a layer 2 device? Because L2 switch works only with MAC addresses. That is why Any device which works with the MAC addresses are layer 2 devices. L2 switch interface do not have any MAC address or IP address. So you can see this is the L2 switch interfaces. And you can see that the L2 switch interfaces do not have any MAC address or IP address. It just have port numbers, and port number are just numerical values. Machine E, D, F are the machines which are present in the same subnet. So machine E, machine D and machine F are present in the same subnet. Why they are present in the same subnet? Because they all have the same network ID. The network ID is 12.1.0/24. In fact, the interface IFR of the router is also present in the same subnet as machines E, D and F because it also has the same network ID. L2 switch or bridge maintains a table called MAC table. So remember, L2 switch works with MAC table, which is populated using a procedure called MAC learning. So we will discuss the details of MAC learning. MAC table contains a mapping between the MAC address and the port number. So we will see how MAC table is populated, what is MAC learning, and what does the MAC table actually contains, and how the content of the MAC table is used to avoid the problem of thrashing. So in the next slide, you can see the MAC address, the MAC table of the L2 switch. And in this slide, we show you the fully populated MAC table. That is how the fully populated MAC table looks like. So from the table, if L2 switch receives a packet with destination is equal to MAC address, that is ME, that is if L2 switch receives a packet in which the destination MAC address is specified as ME from any interface other than P4, that is the packet may arrive from here, packet may arrive from the port P3, or the packet may arrive from the port P2, and the destination MAC address in the packet is ME. What will the L2 switch do? The L2 switch will look up its MAC table with ME as key and finds that the packet should get out of the port number P4. So L2 switch will forward the packet on the port P4 because it has a table in its MAC table, because it has an entry in its MAC table. Thus only E would receive the packet, and no other machine in the subnet is unnecessarily thrashed with the packet not destined to it. And also, when we talk about the routing in data link layer, we should call a packet as frame. Remember that it's a terminology. A packet is a packet on the layer 3, right? So on a layer 3, we call the packet as a packet. On layer 2, we call a packet as frame. So this is how L2 switch works. Now we need to learn how this MAC address table is populated. That is, who installs the entries in this MAC table and how these entries are installed. So L2 switch does the process called MAC learning. It is through the process of MAC learning that the entries in the MAC table are inserted by the L2 switch. Let's see how. So let us see how L2 switch populates its MAC table. So L2 switch, as I said, L2 switch is also called a bridge. Make an entry in the MAC table from the contents of any ARP request or reply message or normal data packet it forwards. So whenever L2 switch receives any packet from any machine which is connected to its port, the L2 switch performs MAC learning. Now that packet could be data packet, it could be ARP request or reply message. In other words, it could be any packet which has Ethernet header. The L2 switch passes the Ethernet header and does MAC learning. So whenever L2 switch do not have entry and do not know which port to forward the packet to, it floods the packet out of all the ports except the port from which the packet is received. It floods the packet out of all the ports whenever it don't have entry in the MAC address table and whenever the L2 switch do not know how to forward the packet because they do not have the entry for that particular MAC address in its MAC table. So L2 switch populates the MAC table by inspecting the source MAC address of any packet it receives. Remember, any packet. It could be any packet which has Ethernet header, and inside that Ethernet header you will have source MAC address. So L2 switch populates the MAC address table by inspecting the source MAC address in the Ethernet header of any packet that bypass the L2 switch. L2 switch forwards the packet to correct port number by inspecting the destination MAC address in the packet it receives. So while forwarding the packet to the correct outgoing port, the L2 switch inspects the destination MAC address, whereas population of the MAC address table is done using source MAC address. So let us take an example. Suppose the machine E wants to send a data packet to the machine F. So the first thing that E would do is to launch the R broadcast request to learn F's MAC address as before. So let us assume that the machine E is not aware of F MAC address. So machine E will launch a R broadcast request. So on this interface, that is IFE, machine E will send an R broadcast message. L2 switch receives R broadcast request on port P4, that is here, and reads source MAC address in the packet. So what will be the source MAC address in the packet? The source MAC address in the packet will be ME. So L2 switch concludes that the machine E sits behind the port number P4. It makes an entry in the MAC table and floods the R request on all the ports. So in the MAC table, L2 switch will make an entry that the MAC address, that the machine which has the MAC address ME is sitting behind the port number P4. Like earlier, only F replies to R request message. Why? Why F replies? Because the destination IP address that is specified in the R broadcast message is the IP address of machine F. Therefore, only machine F replies to R broadcast message. And in that reply, the destination MAC address is the MAC address of machine E, that is ME. Now that R reply is received by L2 switch again on port P2, right? And the L2 switch at this point of time reads source MAC address in the R reply message. So the L2 switch makes an entry that the source MAC address that is specified in the R reply message and the port number from which the R reply message has been received. So L2 switch concludes that the machine F sits on the port number B2. It makes an entry in the table. So again you can see that whenever the L2 switch receives any kind of packet which has Ethernet header attached to it, whether it is R broadcast message or whether it is R reply message or whether it is a normal data packet. So L2 switch reads the destination MAC address in the R reply message, look up its MAC table with destination MAC as key. And since destination MAC address in the R reply is the MAC address of the machine E, and there is already an entry for that in the MAC address table of the L2 switch, L2 switch knows that the R reply message should be forwarded out of the port P4. So L2 switch forwards R reply to port P4. E receives R reply, and now E can carry out communication with the machine F because E has now resolved the R. So the final conclusion is that L2 switch is a layer 2 device because it works with the MAC addresses only, and as you can observe, it works only with MAC addresses. This completes our concept of L2 routing. So here in this diagram, I have shown you the fully populated MAC address table of an L2 switch. And you can see it contains the mapping between the MAC address and the outgoing port of the machine. For example, the MAC address ME of the machine E, and the machine E is behind the port P4. And when this entry was made, this entry is made when E had sent any type of packet to L2 switch, or whenever L2 switch had received any type of packet generated by the machine E, L2 switch must have made a entry into its MAC table. Similarly, had the router had sent any kind of packet and that packet happens to pass through L2 switch, the L2 switch must have read the source MAC address specified in the Ethernet header and must have made an entry that the MAC address MR is sitting behind the port P1. And likewise, the entry MF and MD is also made by the L2 switch. So this process is called MAC learning. So MAC learning is done whenever the L2 switch receives any kind of packet which has Ethernet header attached to it. So there are 2 points to be noted here. The L2 switch, the MAC learning is done using source MAC addresses, and the forwarding of the packet by L2 switch is done using destination MAC addresses. So these are the noteworthy points regarding L2 switch. Third point could be that L2 switch populates its MAC address table using Ethernet header.